All right, Ms. Whitaker here, and we're going to go over this writing equations homework. I asked you just to do slope-intercept form, so we've got to keep in mind that's y equals mx plus b. So for number one, I need to find out the slope and the y-intercept. Slope is rise over run, so rise over the run is 1 over 3. So my slope is 1/3 x, 1/3 is my slope. And then I got to find the y-intercept, which is at positive 2, so it's plus 2. So y equals 1/3 x plus 2 should be your answer, where m is your slope and b is your y-intercept. All right, on number 2, I told you that we weren't able to see what the y-intercept was going to be. So we were going to have to take the slope and plug in one of the points that were given into slope-intercept form. So we're going to have to do a little bit of work here. So plugging into y equals mx plus b, let's find out what the slope is first. So let's take our points. I know it's a negative slope because it's going down from left to right. My rise is 1, 2, 3, 4, 5, and over 1. So it's a negative 5x plus b. Now let's just take one of these points. Let's take this point right here and plug in for our x and y values. So this is at 1, 2. That's my x, and this is my y. So we would plug that into our equation. So 2 instead of y is equal to a negative 5. That's my slope. And then times the x value, which is 1, plus b, which is what I want to solve for. So now I have 2 equals negative 5 plus b. Now I want to isolate the b, so I'm going to add 5 to both sides. So b is equal to 7. So to rewrite, knowing what the slope is, and my y-intercept, y equals negative 5x plus 7. Number 3, I know my y-intercept and I know my slope, rise over run. I know it's a negative slope. Going down 1, 2, 3, over 1, 2, 3. So 3 over 3 is 1. So negative 1x, 1, 2, 3, 4, plus 4 for my y-intercept. I can't rewrite it without the negative 1, so just a negative x plus 4. All right, number 4. If you didn't already notice that this is the graph for y equals x, just find out what your slope is. Up 1 over 1, up 1 over 1, so it is y equals 1x. My y-intercept is at 0, but I don't need the 1, and I don't need to add the plus 0, so it's just y equals x. All right, on number 5, my y-intercept is 0 again. I just need my slope. So I'm going up 2 over 1. It is a positive slope, so y equals 2x. I don't need to add the plus 0. And then number 6, I know my y-intercept. I can find out my slope by rise over run. I do know it's a negative slope. I'm going 1, 2, 3, 4, 5, 6, 7 down, and 3 over, so a negative 7/3 x. And then I'm going down to a negative 3 for my y-intercept. Okay, number 7 and 8 are special circumstances. We have a 0 slope on number 7, and we have an undefined slope on number 8. So we have looked at equations for these kinds of lines before, knowing that in number 7, going across here, my y is always 2 no matter what x is, so my equation just is y is equal to 2. It's a 0 slope, so it would be 0x, so no x's. So I don't need to put an x in there, so I would just leave it at the y-intercept. On number 8, it's an undefined slope, so that means there is no y-intercept. So what this is just saying is that x is always a negative 3, no matter what the y is. So it's just x is equal to negative 3. There's no y-intercept. On number 9, look for the slope. It is a negative slope, goes down 1 over 4. So a negative 1/4 x, and I'm going down to negative 2 for my y-intercept. So y equals negative 1/4 x minus 2. Okay, real briefly on number 10 and 11, you may want to pause it just to make sure you've got everything here, but I just wanted to show you that in number 10, it looks like I start out at $300 because that's money on the y-axis, and it looks like over time, I don't know what the numbers on the bottom represent, whether it's minutes, hours, weeks, days, I don't know. So the big thing I want you to understand is that you have 2 points. You have an x-intercept and a y-intercept, and those represent points as I've labeled up here. So your y-intercept is at 0, 300, and your x-intercept is at 25, 0. So find the slope using the slope formula, y2 minus y1 over x2 minus x1, and you get a negative 12 slope. So your equation for letter B should be y equals a negative 12x plus 300, as 300 is your y-intercept. The x-intercept just means after 25 whatever, there's no money. And the y-intercept is just the money you're starting out with. Number 11, looks like you're earning money. Number 10, money's going away. And then number 11, over time, money's being added. So you're earning money or money's being added over time. I got an equation of y equals 40x. I just kind of came up with a point at when time was 4, then the money was at 160, and it just made it all nice. So just make sure you're somewhere near that equation. It does start at 0. The y-intercept is at 0, so I don't need to put a plus 0 at the end for my equation. The x-intercept is a starting point at 0, and the y-intercept, it means no money at the start, and we just start from there. Okay, the next page, this is the Down the Drain Plumbing Company. We're given a table showing hours and the cost of those hours. So on the upper right, it says Down the Drain Plumbing Company charges blank for a service call and $25 an hour for labor. So we found that from the table here, that just for coming out, they're going to charge $50 and then $25 an hour for labor. So let's move it up to the bottom part of this chart. Graphing the ordered pairs, what I did was I went up every 25. So let me graph that. Okay, so I have my graph. I've labeled my axes. I have cost on my y-axis, hours on my x-axis, because the cost depends on the number of hours that he's working or she's working as the plumber. I do start out at a y-intercept of 50 just for the service call before any hours are worked. So then on the lower right, if I want to write an equation with C representing the cost and H representing the hours, I would do this very similar to slope-intercept form, except instead of y and x, I'm going to use C and H. So that would be the cost is equal to $25 per hour plus the $50 service call. So that would be my equation. So let's turn the page over for the next activity. Okay, so we're going to use the information from the previous page to answer these questions. So the independent variable in this situation is the hours that they're working. The dependent variable is the cost of the job, which depends on how many hours. Number 2, a statement describing the relationship between the variables is just a dependence or a dependency statement. So cost depends on hours worked. And reasonable domain. Domain, remember, is all of our inputs, all of our x values. And we can't have any negative hours worked, so we know it's going to be greater than or equal to 0. We know that he could possibly work 0 hours, so that's a possibility. So it's everything greater than or equal to 0. That means our range is going to be everything greater than or equal to $50. That's it. That's the lowest we're going to go for the range. So think about what's the lowest or what's the highest, whatever your situation is. And then number 4, what does the ordered pair 050 represent in this situation? That's just the service call fee before any hours are worked. So the y-intercept is just the service fee, just to come out. Alrighty, starting on number 5, I told you instead of doing 2 different forms, just to focus on slope-intercept from a table. So what we normally do from a table to find slope is look to see what the change is in our y's Now, I do want to mention, and we'll talk more about this on the review, that we don't always have the same increments between our y's and between our x's, but we just need to think about all we're doing in a table is taking 2 points, taking these points and our y values, finding the difference of our y's and putting it over the difference in our x's. So going from 0 to -4, I'm subtracting 4. Going from -4 to -2, I'm adding 2. So I would put a -4 over 2. So that would give me a slope of a -2. So I'm going to start my slope-intercept form. Y equals a -2x. And then I just have to figure out what my y-intercept is. Now I know it, my y-intercept, x is 0. And all you need to do is look in your table for when x is equal to 0. That should be my y-intercept. So -8 for the remainder of my slope-intercept form. All right, on number 6, I notice right away that no matter what x is, y is always equal to 5. So that's just going to be my equation. Y is equal to 5, no matter what x is. Number 7, I'm going to look at my change in my y's. Looks like I am adding 0.4 here. And from here to here, I'm adding 1. This seemed to be adding 0.4 each time. So it was the same increment each time. Now, it's not always going to be the same increment from number to number. You just have to be consistent with putting the 2 points that you're using. Say I could use these 2 points right here and say the difference is 0.4 over 1. So 0.4 over 1, which leaves me with a slope of 0.4. So y equals 0.4x, and my y-intercept is at -2. It doesn't matter which 2 points that you use to do your change in y's over your change in x's, your slope should always be the same. And because of that, we noticed in number 8 that we had some irregularities. I'm assuming that this should have been a 2 and just a typo. But if we treat it like it's not a typo, then we know this is not a straight line. And we can't do a linear equation for something that's not a straight line. So we had a problem on that one. And then on number 9 quickly, I can see that no matter what y is, x is always equal to 3. So my equation for that is always x is equal to 3. All right, next page, we're talking about writing linear equations given 2 points. So we're looking at this flight and talking about altitude as it goes up and how far it goes up each second. Letter A, what ordered pair shows the altitude of 2 seconds? So that would be 2, 5, and actually it would be 2, 5,000. In letter B, what ordered pair shows the altitude at 10 seconds? That would be 10, 9,000. If we want to be technical. Now, I know it's on the y-axis, it has numbers there, but if we're talking about what that represents, it's in thousands, the height in thousands, so I guess we need to be a little bit more accurate in our points. The slope is going to be 1,000 feet for every 2 seconds. I'm going up 1 and over 2, but up 1 means 1,000 feet. And then over 2 is 2 seconds. So 1,000 feet for 2 seconds simplifies to 500 for 1. So 500 is my slope, and that represents 500 feet per second that it's rising, which is pretty fast. And then letter D, write the equation in point slope and convert to slope intercept. We just talked about focusing on slope intercept. So that would be y is equal to 500x plus 4,000 if we're dealing with those thousands of feet. The y-intercept is at 4,000. What does it represent? Or is it 4? You could say it represents thousands of feet, 4,000 feet. This is the altitude where it started being recorded. That's just when they started recording the altitude per second. All right, letter F, after how many seconds will the altitude be 13,000 feet? I just set, using my equation up here, I plugged in 13,000 feet, so 13,000 is equal to 500x plus 4,000. Subtract 4,000 from both sides, so you get 500x is equal to 9,000. And then you divide both sides by 500, and you should get 18 seconds. Letter G, what will the altitude of the plane be after 30 seconds? So you're plugging in 30 for x, so it'd be 500 times 30 plus 4,000 should get 19,000 feet. And then letter H, the reasonable domain. X is greater than or equal to 0 as far as times in seconds. And then your Y would be greater than or equal to 4,000 feet, or 4, however you are translating your y-axis. Alrighty, number 2, a man whose foot is 12 inches long wears a shoe size of 12. A man whose foot is 10 inches long wears a size 6. Write an equation of the line. So I used my 2 points of 12, 12, and 10, 6. So I'm going to find the slope first. So I used the slope formula and found a slope of 3. Now I just need to find my y-intercept. So if I plug into y equals mx plus b and take one of these points, I'll just choose that one, and then my slope, so then I'll have 6 is equal to a slope of 3 times 10 plus b, and so that will give me 6 equals 30 plus b. Subtract 30 from both sides, so b is equal to a negative 24. So my equation is y equals 3x minus 24. All right, let's go ahead and start down here on the bottom. First thing I'm going to do is find the slope using the y2 minus y1 over x2 minus x1. So I found a slope on number 3 for 1. And then I'm going to plug in that slope in one of my points. It doesn't matter, just choose one. So I would do, let's choose this one. So 7 is equal to a slope of 1 times my x value plus b. So 7 equals 3 plus b. Subtract 3 from both sides. So b is equal to 4. So my equation is y equals x plus 4. Number 4, do the same thing. You should get y equals negative 6x plus 4. All right, finishing out this page, I just wrote down the slope and the slope-intercept form for each problem. So just go ahead and pause and check your answers. Remember, for these, I just turned them into slope-intercept form, and I plugged in one of the points, the x and y values of one of the points, into slope-intercept form, given the m, given my slope, to solve for the b each time. So once I find my b, then I have my slope in my b, and I can plug into slope-intercept form. All right, on the last page of the homework, just slope-intercept, given one of the 3 table, graph, or equation. And the number 1, I'm given the equation, so I'm going to graph that first. I'm just very tempted to graph that. And that's just x is always equal to a negative 4, and it just doesn't matter. Doesn't matter what the y is. X is always a negative 4. And that's what that would look like. On number 2, I'm given the x and y values in a table. So I'm going to plot those first. So I have one at a negative 4, 0. I have one at a 0, negative 2. And I have another point at 4, negative 4. I can connect those. That's what the graph looks like. I can figure out what my slope is by doing rise over run. It's going up 2 and over 4, so that reduces to 1/2. I know this is a negative slope, so I know it's going to be a negative 1/2 x. And I go down to my y-intercept of minus 2. Now you could say plus a negative 2, but I would prefer to see minus 2 for your equation. And number 3, they're giving me the points on a graph. So I'm going to put those over in my table. I see that I have a point at a negative 2, 1, and I also have another point at 2, 3. And I'm going to find what the difference in my y's. I'm adding 2. difference in my x's, I'm adding 4. So I could also see from the graph that it's a positive up to over 4. So that would be 1/2. So I know my slope is 1/2. And then I'll put the x, and my y-intercept is right there at 2, going up 1 over 2, so plus 2 for my y-intercept. Alrighty, number 4, Amy opened her bank account with $100. She adds $30 each month. The slope is $30, and I'm assuming my x-axis is in months. And my y-intercept is $100. So that's where she's opening her account, starting out at $100. So the equation is going to be y equals 30x plus 100 in the form of slope-intercept. Letter C, how much will she have in her account after 4 years with no interest, assuming. Now, remember that it's $30 per month. So I'm going to change the 4 years to 48 months. And then plug that into the equation. So 30 times 48 plus 100, and you should end up with $1,540. And then when will she have 730? So that, all right, sorry for that interruption. Letter D, she'll have 730. We'll just plug in 730 for the y and figure out, let's just solve for x, figure out how many months. So we find out that's 21 months. On number 5, identify the slope at a -3 pounds because he's losing pounds. So -3 for the slope, and 270 is where he starts the diet. So that's your y-intercept. So the equation of the line is y equals -3x plus 270. How long did it take him to reach 180 pounds? So 180 would be our y, and we just solve for x, and we find out that that's going to be at 30 weeks. So good job. That's almost 100 pounds. All right, finishing out this page, number 6. I'm just going to go ahead and do slope-intercept form. No need to create situations. I mean, you can make up just about anything you would want to. For number 6, the slope is 10. My y-intercept is at 25, so y equals 10x plus 25. Number 7, y equals -5x plus 500. And number 8 is just y equals 4x. My y-intercept is at 0, so I don't need to put plus 0 at the end there. And then continuing on with slope-intercept form, given slope and my y-intercepts. So number 9 is y equals x plus 10. I don't need the 1x plus 10, so just leave the 1 off. Number 10 is y equals a -3. The slope is 0, so I know it's a horizontal line at y equals a -3. And then 11, slope is 2/5, so y equals 2/5 x minus 3/5. And number 12 is y equals 20x plus 100. Number 13, y equals a -3x. My y-intercept is 0, so I don't need to put plus 0 at the end. Number 14, it's a -x minus 7. Y equals -x minus 7. Again, you could do plus a -7 at the end, but I would prefer -7. All right, so if you have any questions, just let me know tomorrow. Otherwise, tomorrow in class we're going to review for the test on Thursday. So if you are still feeling a little fuzzy on slope or slope-intercept, please go through the previous web resources on the previous concepts page. And let me know if you have any questions.